The Group 12 now start the project present. This project have five parts, include the method background, the methodology, and research tools. Then the core results of the project planning, the cost optimization analysis based on Excel software. Final, the conclusion of the entire project. The first part is the motivate and background. The Pearl River Delta had cross-river transport bonus. Post-Asian Fluency crisis, the 2002 Hong Kong-Zhuhai-Macau Bridge, the world's longest sea crossing launched. Our company took its infrastructure part, gaining core technology and crossing regional experience. For the industrial background, the Greater Bay Area updates public infrastructure with cross-border transport optimization as a priority. We used the three-tier work breakdown, CPM plus PERT and BOQ pricing. Our focus equipment compatibility for the tunnel's soft soil and high-pressure work geology, and equipment selection optimization, underwater tunnel risk management, and existing research is the three parts for the system optimization analysis. And then is the project details. Our task 316 immerse tube selection, 120 to 115 budget, and 12 months timeline. For the core team, we have 36 people for the core workforce and 10 people for technological management and 7 people for logistics support. And then is the key facility. Perhaps factories 2,000 ton balls and bedroom monitoring. Then for the cost of material, 14,400 ton rebar, 108 kilometers C50 concrete. The cost all follows the Hong Kong Public Works standards.
Hi, I will talk about the methodology and the research tools. So our main question was how can we check if our work was good enough? Our plan had 3 simple parts. First one is to look at the numbers. We took the project and broke it into very small pieces, like a receipt. We looked at the time, the cost, and the material for each small pieces. This helped us to see whether the whole project clearly. And the second one is to compare with others. We look at other big bridge projects. This helps us to see what we did well and what was normal. And the last one is to use simple rules. We didn't make new rules, but we used the simple, strong rules that everyone knows, and we changed some a little bit to fit our project. For example, we added extra days for better weather and the extra cost for some situations. And then I'm going to talk about the research tools. We use the Microsoft project to make the schedule and plan, and then we use the Excel to count all money and the costs. And the last one, we use the SPSS to check if our concrete was strong enough. So what is its final result? Our method is like a strong foundation. It helps us to prevent what would work well and what was learned. This is not just a story, it's like tracking the truth. This can help us to be better on the next big project. And now I'm going to pass the mic to my group mate.
Well, this part is called results of project planning. First, work breakdown structure. We use a 3-level hierarchical structure to clarify the responsibilities and the priorities of each work package. Well, you can see the level 1 to 3 and the priorities, low, medium, and high. Well, second, detailed schedule. The critical parts runs 312 days, and the 48 days buffer helps hold potential delays like bad weather or equipment malfunctions. Well, you can see the text name, duration, start day, end day, dependence, critical parts. Well, second, cost estimation. Well, the costs made up four parts concludes material cost, labor cost, equipment cost, and contingency cost. Well, because of the calculation logic, we can get the amount. So we can know the material cost amount for 75% and labor cost 12%, equipment cost 11%, contingency cost 2% and 2%. Well, so their total cost is about 157 million. Well, the next part is project control plan. Well, first, schedule control. We use EVM to track progress weekly. If SV falls below 18 days, our SPI drops below 0.95, we trigger an emergency response. Well, so this is the methods about how to control the schedule. Well, next is cost control. We look the optimized total cost as the cost baseline. If actual cost exceeds the baseline by about 5%, we launch a cost review. So there are many methods about how to control cost. Well, the last one is quality control. Well, we need to generate daily quality reports through sampling, testing, and resolve non-conformities within 24 hours. Well, that's all. Thank you.
Now I would like to share the core achievement and results of planning in our team project. Primarily, according to the scientific planning and work breakdown schedule shown above, we assume that the project is scheduled to kick off on January the 1st this year, and I use software to arrange this Gantt chart. Initially, the duration of the whole project reached to 332 days, which will assist the team budget. Therefore, we decide to run the prefabrication and floating transportation to start on day 200 instead of day 231. This cuts the critical path by 30 days. The critical path covers entire process, including 19 tasks in total, which are shown below as the flow. Then our project adopted the CPN and PRT chats network to sort out the workflow. AON chat, the activity on nodes, is a network planning technique for project schedule planning. Its core principle to use node to represent project activity and arrows to only indicate the logical dependency relationship between activities. Next is the AOA chat, activity on arrow network. It's quite similar to AON chat, but the difference is the activity are represented by arrows and nodes denote the logical relationship or events between activities. Okay, that's the entire introduction of my section. For the next part, the cost optimization analysis will introduced by Liu Haoyu.
Next, I will explain a part of cost optimization analysis based on Excel software in this project. The core of this section is to minimize the total project cost while meeting the project constraints. First, let's clarify our optimization objective. On the premise of ensuring the total project duration less than or equal to 360 days and meeting the technical requirements of each subproject, we aim to minimize the total project cost, denoted as Z, unit Hong Kong dollars, and the objective function is shown below. To achieve this goal, we have defined key decision variables, including steel procurement, quantity X1, concrete procurement quantity X2, and overtime hours of core operation personnel X3. Meanwhile, the constraint ranges of these variables are clearly specified. For example, the steel procurement quantity X1 must be more than or equal to 14,400 tons, with its unit price P1 fluctuating between 3,700 Hong Kong dollars and 4,000 Hong Kong dollars per ton. The concrete procurement quantity X2 must be more than or equal to 108,000 cubic meters, and its unit price P2 ranges from 460 Hong Kong dollars to 500 Hong Kong dollars per cubic meter. Additionally, the shortening duration of this equipment X4 is less than or equal to 15 days. The quantity of reusable formwork X5 is less than or equal to 75 sets and must be an integer, and all variables satisfy the non-negative requirement. Beyond the constraints of variables themselves, we also need to comply with three types of core constraints. Firstly, the duration constraint. We calculate through formulas to ensure the total duration does not exceed 360 days. Secondly, the material usage constraint and equipment lease duration constraint, which guarantee the technical compliance of the project. Thirdly, the formwork reuse constraint, which maximizes the efficiency of resource utilization. And there are also some constraints related to the decision variables, which have been explained earlier. In the practical operation of Excel software, we set the targeted cell as the total cost calculation item, took each decision variable as the adjustment object, and after entering all constraint conditions, selected the GRG nonlinear solving engine for optimization. This type of engine is suitable for smooth nonlinear problems and can accurately find the optimal solution. And the last part is the final optimization result is very satisfactory. And we have proposed three key optimization methods. Firstly, purchase steel and concrete in bulk to reduce the unit price by 8%. Secondly, shorten the floating crane rental duration from 90 days to 75 days. Thirdly, reuse 15 sets of formwork. Through this series of adjustments, the total project cost has dropped to approximately 139.95 million, successfully falling below the budget ceiling of 150 Hong Kong dollars, and fully achieving the cost optimization objective. The bone is a cost optimization analysis part that I'm responsible for. The core lies in realizing accurate cost control on the premise of compliance through scientific variable definition, constraint setting, and application of the software tool. That's all for my presentation. Thank you all.
To conclusion, the project plan has successfully shown that with a comprehensive and structured approach, it's flexible to handle such a complex part of the immersed tube tunnel in the Hong Kong-Zhuhai-Macau Bridge project. The application of the effective project control tools regarding time, cost, and quality maximum to ensure that all projects stay right on track helps reduce all feasible risks in project, including such pre-construction project. The overall feasibility with regard to time has been confirmed by this plan, along with proper time and effort allocation. By providing such a comprehensive critical path method schedule include in this plan, the initial cost estimate was further improved by applying optimal analysis. The overall effect of applying measures such as mass material purchase, optimal equipment rents, and reusing resource has caused the overall project cost to come down significantly as per client's financial constraint. Our project, this plan not only highlights that we possess excellent execution and overall cost manageability, but it can also serve as an excellent example and effective reference in carrying out upcoming long-range massive infrastructure project. That's the end of our group project presentation.